Hi, how are you? I want to talk about chemistry today. Oh my gosh, did I lose part of you? Did you literally just turn me off? I hope not. What I'd like to do is I'd like to talk about 3 different specific chemical compounds that are present in frankincense. Now they're present in other oils too, but it just is an amazing thing to consider when you consider that Jesus received frankincense as a gift from the wise men. And then I'm going to tell you what I'm about to tell you. It's a wonder. It's one of those things that makes me smile, and it's just it's an amazing show of how much God loves you. It really is. It's a awe-inspiring and mind-boggling, to be honest with you. That's where I go. And you're like, there is no chemistry that does that. But I promise there is. So I'm going to shoot this in 3 different parts so that you have 3 different bite-sized pieces. And you will see those posted over the next few days. And that way you can kind of saturate and learn and get in on this chemistry too. So you can be awe-inspired as well. So frankincense, the very first chemical compound I want to talk about is phenylpropanoids. Phenylpropanoids. Ugh, I know, you're like, really, I don't want to hear about phenylpropanoids, but you really do. Okay, so pretend like that my hand is a cell, okay? Any cell in my body, and there are these little things that stick off of that cell that are called receptor sites, okay? They are amazingly made to only accept a particular type of chemical inside each one, okay? This directly affects how this cell functions, okay? So this receptor site is here on this cell, and let's go to the periodic table. If you have to Google once this is over, then Google it. Okay, so the example I'm going to use is iodine, all right? If you look at a periodic table and you are looking at columns within the periodic table, everything in this column has the same valence. What does that mean? It has the same number of electrons that it needs to bind, okay? So you've heard of free radicals, right? Free radicals are those chemical compounds that come inside your body, minerals sometimes, that come inside your body that are looking for something else to attach to in order to make it stable, okay? Excuse me. In order to make it stable. So it needs to be paired with something else. Let's talk about iodine, remember? So the iodine is in the same column as chlorine. Okay? So now I'm going to make your brain go like this and go, you know how sodium chloride is something that we talk about, and how iodine is something that's added to your salt. Why? Sodium and iodine, this pairs with this because that way it can be taken into your cell and into your body for absorption. But chlorine, or chloride in this particular, but chloride, what it does is it has that same sodium. It has the same valence. It has the same number of missing parts, if you will, that need to attach to something. All right, so that is an example of why we don't drink chlorinated water. What that chlorine can do is it can come in, and here's your receptor, and that receptor right here is looking for a specific compound. But guess what? This receptor can be fooled, and instead of accepting iodine here, it will accept chlorine here. And so now this causes this, which is attached, to not function the way it's supposed to function. It's the wrong chemical. It fooled the receptor, but the cell can't function the way it's supposed to, okay? So that's just one reason why we don't drink anything that's got chlorine. And if you want to do a little study, oh my gosh, the number of things that we have in liquid form that are available and have chlorine in it is astounding. Oh my gosh. Just Google it. There's a toxic chemical for you. Okay, so now that we have chlorine attached to this receptor and this cell cannot function properly. One thing that we can do is use frankincense. Frankincense has phenylpropanoids. What does that do? Phenylpropanoids go in and they scrub receptor sites clean. Phenylpropanoids go, oh, you fooled that receptor, but you don't fool me. I'm going to get you out of here. And it scrubs it clean so that you have an open receptor site for iodine to come in and attach. Okay? So phenylpropanoids are pretty smart because they go, no, you can't stay here. And anything that's not supposed to be there, it scrubs clean. That's a pretty amazing fact. Come in next time and let's discuss the next compound that can help you and your body function the way it's supposed to.